All right, so today we're going to look at a couple other sampling techniques. So last class we talked a lot about things that were bad, like convenience samples, voluntary response samples, and we talked about how really you want to be doing more of a simple random survey. But I did mention there are other techniques that are just as valid and sometimes superior. So that's what we're going to take a look at today. And we're going to start with one called the stratified random sample. All right, and a stratified random sample, here's how that goes down. All right, so first, the population is classified into groups of similar individuals. All right, and we call those groups strata. Then a SRS is chosen from each strata. All right, so the example I always go with is think about our high school. We have freshmen, sophomores, juniors, and seniors. So a stratified random sample would be me dividing the population of Ichabod high schoolers into 4 different groups: freshmen, sophomore, junior, seniors, and then taking an SRS from each of those groups. So instead of just randomly surveying the entire building, being like, all right, I'm going to take this many from the freshmen and I'm going to randomly select them. I'm going to take this many from the sophomores and I'm going to randomly select them. I'm going to take this many from the juniors, randomly select them, this many from the seniors, and randomly select them. So I'm guaranteeing that I get representation from each grade. Right? And this says if the individuals in each stratum are less varied than the population as a whole, which basically means that each group has something that makes them unique, like freshmen are different than sophomores, that are different than juniors, that are different than seniors. A stratified random sample can produce better information about the population than an SRS of the same size. All right, so the idea there is by guaranteeing that you're hitting those groups, you don't have to worry about potentially having an SRS where you underrepresented freshmen or you overrepresented seniors. We can ensure that we're getting balanced representation across the groups, and generally that can give us superior results compared to an SRS of the same size. So this is one of those techniques that we use and can actually be an improvement over the SRS. All right. Next one, the cluster sample. All right, first, the population is divided into smaller groups that mirror the characteristics of the population. All right, so what exactly does that mean? Again, I'm going to go back to our school here. All right, let's pretend we divided our school into the 4 different wings. So the 200 wing, the 100 wing, the 300 wing, the 400 wing. Now, I'm not talking about homeroom, but if you just at a generic random point during the school day, if you looked at just the 100 wing, there would probably be a range of kids in there. All right, there'd be some sophomores, there'd be some juniors, there'd be some seniors, there'd be some freshmen, but that one wing would be a microcosm of the school as a whole. Same thing for the 300 wing, same thing for the 400 wing, same thing for the 200 wing. Each wing would be like a miniature version of the school. All right. Notice how it's different than the strata where I divided people by some characteristic. Right here, I'm not dividing them by some defining characteristic. I'm just saying, okay, this region, which mirrors the school as a whole, is one group. This region over here, which mirrors the school as a whole, is another group. and I'm kind of creating almost like miniature schools. Once I have those, then a SRS of the clusters is taken, and all individuals in the chosen clusters are part of the sample. All right. So down here, it says strata are similar within, but different between. Clusters are different within, but similar between. So what is that saying? Stratas are similar within, like all the freshmen are together, all the juniors are together, all the sophomores together, all the seniors together, but each group is different, all right? That's why we broke them up into groups in the first place. Clusters are different within. Each cluster has a few freshmen, a few sophomores, a few juniors, a few seniors, but similar between, all right? Each cluster is more or less like any other cluster that we could create. It's just that each cluster is a mix of different people. And again, the best example I can do is just the school. All right, stratified is dividing them up by grade. Clusters is dividing it up by a wing at any given time. You know, each wing has a range of students in it across all grade levels. So those are your clusters, whereas strata is actually dividing it up by freshman, sophomore, junior, senior. Okay. So both of these are valid, reliable ways to conduct surveys. Other ways that are also good is the systematic sample, which we saw a little bit on the warm-up, but that's just where every nth individual is chosen. And if you have something where it's time sensitive and you want to make sure it's spread out through the day or through the week or through the month or whatever, you know, this can be a good way of doing it because you're ensuring that all of your, you know, surveying's not coming from the same point in time. You know, especially the example we had on the warm-up was manufacturing. You know, this is probably a good way to conduct a sample in manufacturing so that you're ensuring that you're getting stuff that's been produced throughout the day and not just at one time or the other. You know, maybe people make more mistakes right before lunch and they're more accurate after lunch or something like that. But either way, by doing it this way, you're kind of guaranteed that they're going to be spread out over a time period, which may have real world benefits for you. So again, a valid way of doing it that can actually be beneficial depending on what you're concerned with. All right, then we have the census, which is when all members of a population are surveyed. And a census is great if you can do it. It's just practically very difficult to do. It's usually pretty expensive. I mean, that's why as a country, we only conduct the census once every 10 years. And even when we do that, there's no way we're getting everybody, all right? We're definitely missing people and we're not talking to everyone, but it's a goal, you know, and it's the more you talk to, the more likely your estimates are going to be the true value of the population, you know, because again, that's what we're always trying to do. We're trying to estimate things about the population from our samples. Well, if our sample is the entire population, we don't have to estimate anymore. And while that's probably never going to happen, the closer we get, the more confidence we can have in our estimates. All right, so let's take a look here. Student council wants to conduct a survey during the first 5 minutes of an all-school assembly. All-school assembly. Remember when those could happen? In the auditorium about the use of the new school library. There are 800 students present at the assembly. A map of the auditorium is shown below. Note that students are seated by grade level and the seats are numbered 1 to 800. So this is a very convenient school. because apparently they have exactly 800 students with 200 in each grade. And the seats line up in a way that it's going to be super convenient for us. Now, is real world going to be always this convenient? No, but it's, it serves our purposes for what we're doing right here. All right. So a couple of things to note. There are 20 seats in a row. Which means we have 40 rows in total for the 800 students. All right, that's just going to be relevant when we talk about how we're going to set up these samples. All right, so describe how you could generate a sample of 80 students using the following techniques. So this is something you're going to have to do a lot in this unit. You're going to have to do it on like a test and things like that, but you're basically going to have to describe how you would actually conduct a simple random sample, a stratified random sample, a cluster sample, or so on and so forth. So this is sort of step one in just the kind of language and technique that I'm looking to see. All right, so how could we generate a sample of 80 students using the following techniques? If we wanted to do a simple random sample, we could say something like, we would generate 80 unique random numbers from 1 to 800 and select those students. All right, so I'm underlining the word unique because technically, if you were just generating random numbers, you could potentially generate the same number twice. So again, when you're writing a full description of your sampling process, you need to specify that you're only looking at the unique random numbers, or that you need 80 unique random numbers, and that you're basically ignoring duplicates. So you could either write, we would generate 80 unique random numbers, or you could write, we would generate 80 random numbers ignoring repeats, but something to that effect. You want to have that level of detail when you're doing it. So a stratified random sample, right? We could say something like generate, and I'll use the other language this time, 20 random numbers ignoring repeats for each grade in the appropriate range. So, for example, like 9th grade would be 601 to 800. 10th grade would be 401 to 600. 11th grade would be 201 to 400. And 12th grade would be 100 to 200. All right. And again, that's just coming from these seat numbers here. All right. So generate 20 random numbers, ignoring each for each grade in the appropriate range. Those students would be your sample. All right. So again, we're breaking it up and saying, all right, we're forcing ourselves to get 9th graders, 10th graders, 11th graders, and 12th graders. Now, the cluster sample is where we get a little silly because we just have this school lined up in such a neat and uniform way. But the idea is the same. We can think of each column as a cluster of 40 students. All right, so it said there were 20 seats in a row, so that's going across. There are 40 rows. So each row is going to have some freshmen, some sophomores, some juniors, some seniors. So each row is only going to have a single. So the rows are your stratas. The columns are your clusters. All right, when we go across a row, it's all the same grade. But when we go up and down a column, we're getting a little bit of each in every column. So cluster sample, we're going to create clusters. Using the columns of the auditorium. Each cluster has 40 students, 10 from each grade. All right. So if we're trying to survey 80 students, we're going to need to generate 2 unique random numbers from 1 to 20. Select those 2 clusters and survey every student in the cluster. All right, so instead of selecting individuals, we're now selecting entire clusters, and then we just talk to everyone in that cluster. All right, whereas the stratified, we were still just randomly selecting individuals. We were just saying from this group, from that group, from this group. So again, it's kind of the difference between those two. And then last but not least is the systematic sample. You know, there's 800 people here. We need 80 people in our sample. So we might just say something like survey every 10th person that enters the auditorium. All right, and assuming they enter by grade or they're called down by grade, we're going to get a pretty good mishmash of kids from every level. All right, so again, this is kind of just how you can describe and the sort of detail you're going to need to be writing when you talk about these different approaches to sampling. All right. So let's make sure that we can identify these and make sure that we're clear on which is which in some sort of like applied setting. So it says for each sampling example, identify which type of sampling is described. All right, we need to survey a random sample of 300 passengers on a flight from San Francisco to Tokyo. Name the sampling method described. So pick every 10th person as they board the plane. All right, this would be a systematic example. And I probably should have said this before I wrote this first one down, but I would encourage you to pause the video right now, try them, make sure that you have a feel for this in your head, and then just check to see if you got the answers right. All right, if all you do is copy down what I have, you're never going to really figure out whether you know it or not. So my advice would be try it on your own first, then come back and see how you did. All right, from the boarding list, randomly choose 5 people flying first class, 25 people flying coach. All right, so here there's a difference between these groups. So these are your strata. All right, you've got two strata, first class and coach, which means this is a stratified sample. All right, generate 30 random seat numbers and survey the passengers who sit there. All right, so we're not putting any restrictions on. We're just saying generate 30 random seat numbers. And that's going to give us a SRS, which again is a simple random survey. And by survey, I mean sample, simple random sample. Sorry about that. Survey, sample, you're saying them a lot. You mix them up every now and then. Survey the first 10 people who board the plane. All right, so if it sounds easy, like, oh, that's like a quick and easy way of doing it, then there's a decent chance that we're dealing with a convenience sample. All right, so instead of doing any sort of actual sampling methodology, you're just like, yeah, I'll just talk to the first 10 people. That would be an example of a convenience sample. All right, randomly select a seat position, right window, right center, right aisle, etc., and survey all the passengers sitting in those seats. So that means you're going to get some first class, you're going to get some cabin. Each of these represents a cluster. All right, so these would be your different clusters. And if I'm saying that these are clusters, it should be obvious then that this is the cluster sample because we're dividing it into groups and each group has a little bit of everything. And then we talk to everyone in the group. All right, hand out a survey to all the passengers as they enter the plane and politely ask them to fill it out and return it. All right, this is basically what we're dealing with when we say voluntary response. Now, this is a little bit more of an aggressive voluntary response because we're actually giving them the survey. You know, a lot of times voluntary response, like the person has to go and search out the survey or they have to like take the initiative to participate in it. In this one, we're at least giving them the survey. So that's a little better, but still, given that there's no incentive behind it, given that we're just kind of being like, oh, you know, fill it out if you want, that would fall under the voluntary response category. And then last but not least, surveying everybody on the plane represents a census. So we could just put census down there for the last one. All right. So again, hopefully you got these. If not, hopefully my explanations explained, help make sense of with the ones you missed. But again, once you get familiar with them, it's pretty easy to kind of identify the situation. 8. How many children? A teacher asks her class, how many children are there in your family, including yourself? The mean response is about 3 children. According to the 2000 census, families that have children average 1.86 children. Why is a sample like the teacher's class biased? All right, so a lot of times kids want to be like, oh, well, because obviously if you're in class, then like your family has automatically at least one kid. But it does say that families that have children. So we're not talking about all families. We're only talking about families that have children. So that's actually not the source of the bias here. The source of the bias is that she's using a convenience sample. And her class may not be reflective of the country as a whole. You know, maybe she lives in an area where people are prone to have larger families for whatever reason. So by only talking to her class, she's getting a misleading result because she's not talking to those places in the country where people usually only have one kid or only have 2 kids or so on and so forth. All right. Why could it be specifically biased towards a higher number? Well, with a small sample, one outlier could have a large impact. All right. So she's only talking to her class. If there's one kid in the class that's like a family of 10, that's going to drag that up. And there's no equivalent low outlier. Like the lowest value you could have is 1, because by definition, if the kid is in the class, they're part of a family with at least one kid. But on the high end, it could go way up. You're dealing with sort of a right skew situation. So one kid with a large family might drag the average way up and give you a higher number there, where it'd be a lot harder to kind of drag it down because there's no equivalent. Oh, I had negative 17 kids. There's no equivalent on the low side. All right. The only possibility is to have an outlier on the high side. All right. 9. In order to assess the opinion of students at the University of Minnesota on campus snow removal, a reporter for the student newspaper interviews the first 12 students he meets who are willing to express their opinion. What method of sampling is this and why? All right. So, a couple of things going here. Who are willing to express their opinion. So there's a bit of a voluntary aspect here. And the fact that it's the first 12 students, there's a bit of a convenience sample issue going on here. All right, so it's a combination of 2 bad techniques. All right, and that's kind of an important point because a lot of times, as a teacher, I'm dividing these into neat categories of, cluster, stratified, SRS, convenience, voluntary response. But a lot of times those lines become blurred and you can kind of have a little bit of this and a little bit of that. And you're going to see that in this number 10 here, where you've got sort of lots of things being sort of pulled together. So in 10, it says, in order to select a sample of undergraduate students in the United States, I select a simple random sample of 4 states. From each of these states, I select a simple random sample of 2 colleges or universities. From each of these 8 colleges or universities, I select a simple random sample of 20 undergraduates. My final sample consists of 160 undergraduates. What kind of sample is this? Okay, so what we have here is actually called multi-stage sampling. Now, for us on this one, it's pretty consistently SRS, SRS, SRS. But the general idea here is each stage could potentially use different techniques. All right, so I could start with, so I could have started with the SRS, and then when I got down to the college level, I could have said, oh, I want graduates and undergraduates, and then move to stratified. Or I could have, set up clusters inside of the universities. But basically, it's this idea that you're kind of sampling across different stages to sort of narrow down what you're going to look for. All right, so this is a new term here that we haven't talked about yet, but it's basically called multi-stage sampling. And each stage could potentially use different techniques. So that's what I'm saying is it's not always totally clear cut. When somebody's actually doing this in the field, they might use a combination of these different techniques to achieve or to develop their sample. All right. So I hope this was helpful. If you have any questions, let me know, and I'll help where I can. All right.